Okay, okay guys, today I want to talk about coronavirus. Yes, everybody's talking about coronavirus. People is scared. I am scared too. But today what I want to do, I want to use math to explain how the coronavirus is spreading around Canada. In fact, what I want to do is I want to get an equation to predict, to make the projection how the coronavirus is going to react next day, next week, next month, because we can predict. If we have the data, we can predict. Here, I'm going to try to increase the information here. We have a table I create, and in this table, I got, look here, I don't know if you can see here, all the information about the infected people from the first day until the day March 21st. And okay, we have a gap here because my guess, the first people infected coming from outside, but I think in March 1st we start to get this infection local here, and you see it's gonna be increased more and more and more and more. I want to show something here. This is the graph I created because I took this data, and this is the graph I got. This is a typical exponential function here, and there is two ways that I can get the information to predict what happened with coronavirus. One of them is the typical equation using algebra, but I also can get the function for this graph, and I can use derivative, and I'm going to get the rate of change, and I also know how many people is going to be infected every day. So I'm going to take the board, and I'm going to show you how I got this equation. Okay, let's go to close the video for a few seconds, and I'm going to continue. Okay guys, so I'm going to translate this graph here, the same graph I have in Excel. This is the y coordinate, and this y coordinate, I'm going to say this is the infected people, and the x coordinate is going to be the date. So this is the function. It's not the exact same function, but it's easy to explain you. This is the latest day. Latest day is March 21st. The day before 20, the day before 19, and so on. Here, between 20 and 21, we have a delta. Delta, this is the delta for infected people. Delta in math is a variation. I'm gonna get this delta when I subtract the day 21st minus 21. And I also have a delta here. Also the delta and also delta. You know that you notice is reducing here or is increasing here. Okay? So based on this concept, I can find the equation that allow me to predict the next information, the next days. So let me say something. This is a series. A series in math, for example, this is a simple series. 1, 2, 3, 4, n. And is the number I want to find in this series. Could be 100, 200, 1000, whatever. But the rule in this series is every time I increase for one digit. For example, I can increase from 2. But what I want to find is this n. I want to find the INF n infected, and it's going to apply the same concept. It's the INFF plus 1 because it's the next day minus the day before. So okay, so we go here, and I'm gonna find the delta INF, the infected people n. But this equation depends from what? Depend from factor, and I need to find this factor. But what is this factor? This factor is, for example, how exposed I'm going to be when I go to outside. How many people is infected, or is the people follow the rule for the social distance, or is the government implementing the right rules to control the epidemic? Is the people respect each other? So I need to find this factor, and this factor is multiplied for the people infected, because what happens is these people is close to zero. Okay, it's okay. If there is not infected people, there is no problem. But if these people start to increase, it's going to introduce the information in this data, because it's direct, it's proportional, because also is this factor increase, is going to increase the equation. So if we have this one, and I want to find this information here, I know the delta is information between the subtraction between the next day and the day before. So I'm going to apply the same thing. I'm going to say the infected people n plus 1, because it's the next day, minus the infected people. And look here, this variable is the same variable here, so I can replace. I'm going to say right now that this information, IMF plus 1 minus IMF m, is equal to this information here. So I just replace. Okay? Okay. And I have this equation, and I want that you notice here, this is a common factor and common factor. So I'm going to isolate this variable here. Equal, because this is negative, is going to be positive. The factor multiplying this one, this is positive. Okay? And because it's a common factor, I can do something like that. I'm going to put this information outside, open parenthesis, factor here, plus 1. Okay, so this is the factor I'm looking for. I don't know the value right now, but I can find. If I find, I can predict how many people is going to be infected. But the important here is what we try to do is we need to, the government and the people, we need to reduce this value close to 1. Because if this value increase, for example, to 3, if we have 100 the first day, is 300. The next day, and the next day 600, and the next day 900, and this is scare for me. And I'm going to show you my prediction, and this is what I scare right now. So what I'm going to do is a trick that we use in math. Look here, I'm going to say f plus 1 is equal to x. I can use t or b or whatever. This is just a variable. I don't want to use this expression here. I want to use only one variable here. And after that, I'm going to replace here. So I can here, infected people plus 1 equal to the infected people, and I multiply for x. And right now, this is the factor I'm looking for, because I can isolate x. I say x is going to be equal infected people plus 1 is this value I have here, and I'm going to pass this value, because it's multiplying, it's going to be dividing. And how can I find this information? Is I go to my table here, and I know, for example, in March 7 I have 6 people, and the day before I have 7. When I divide 6 between 7, it's going to give me this factor here, and I multiply this factor for how many people are infected. It's going to give me 7.68, and 7.68 is could be 7 people or 8 people, but there is not 7.6 people. It doesn't exist. But look here, the next day is 7. Yes, sometimes in this table, let me move here. In this table, sometimes we are going to get different for 10, 20 people. It's okay, because it's a projection. But what is not possible, I'm going to get 500 people the next day, is the next day say it's only 20 or 30. And based on this information, if we have this one here, Sunday, March 21st, I predict for the next Friday, and this is what I scare, maybe we are gonna get between 600 or 700 in only one day. Because what happens right now is, this is a combination between what the people follow the rules and what the government has to do. I believe we don't know yet how many people really are infected. And I believe in 2 weeks, this information is going to be more clear here. And the equation is going to be more exact to predict. But what I know is, I trust in the institution here in Canada. This is a democracy. And the information the government provides is true. The problem is, and this is my only complaint, I believe the government should prevent before, from the very beginning. If they prevent from the very beginning, I believe the situation will be different. But I trust the government right now is trying to do the correct thing, try to fix the problem, because we have institutions. Even if we have liberal or conservative, these people really follow the law. And this is what I trust, that the Canada is going to be able to be successful to resolve this problem. So guys, I hope this information is going to be useful for you. You can use this information. I also have the option to use the derivative, but you need to find the function. It's a little bit more complex. I did, but I am not a mathematician, I'm an engineer. Maybe I'm missing something for the derivative. But this simple equation allows you to know what happened here. Okay, thank you very much for